Okay, good evening everyone. Welcome to the Minnesota Zoo and Our World Speaker Series. We are happy to have you join us tonight. My name is Seth Stapleton and I work with the field conservation programs here at the zoo. And I would like to take this opportunity to thank the Clean Water, Land and Legacy Amendment, which provides funding to make this event free for all of you to attend. To allow wider access for this presentation, we offer live captioning, with an emphasis on live. Our captioner is typing as I speak, having no idea what I'm going to say next, so we ask in advance for your understanding when words may be incorrect. Now I'd like to introduce our presenters for tonight, Dr. Avery Paxton and Becky Child. Dr. Paxton is a marine ecologist and conservation biologist. She earned her doctoral degree at the University of North Carolina at Chapel Hill, where she studied how reef fish rely on rocky reefs, artificial reefs, and shipwrecks of North Carolina for their homes. Avery is now a postdoctoral fellow with the Southeast Zoo Alliance for Reproduction and Conservation, otherwise known as CSARC, and a visiting scholar at Duke University's Marine Lab on the North Carolina coast. She's trying to understand more about how sand tiger sharks use offshore habitats using advanced technologies, and we'll hear more about that in just a little bit. But first, I wanted to introduce Becky Child. Becky has been an aquarist for the last 19 years, 17 of which have been at the Minnesota Zoo. She began her career at the aquarium at the Mall of America in 2000, where she began working with sand tiger sharks. Becky also currently works with our moon jellies in our native herp collection. And herps, for those of you who don't know, are reptiles and amphibians. Her favorite animals are cephalopods, especially octopus and cuttlefish. And I'm partial to octopus as well. So, at that, I will turn it over to Becky.
Thank you, Seth. Welcome everybody to the zoo. I'm really honored to be able to come up to you and talk to you guys tonight about our sand tigers. So Avery's really the star of the show tonight, but I did want to come up and give you a little bit of background on how the Minnesota Zoo got involved with a researcher from North Carolina. So, you know, the running joke for me lately is that I just really want to be south. I like summer. So it's far too cold out, so I like to pretend we're down in North Carolina. So, but we have had sand tigers at the zoo for quite a long time, and so they became something that's interesting to me, like Seth said, from when I started my career. They're fascinating, really, really cool animals, and so I just wanted to dive a little deeper, per se, into sand tigers. So this is kind of our path to how we got involved with wild sand tigers. So Discovery Bay is our current kind of big building for ocean animals, and we opened to the public in 1997. So our 220,000 gallon shark tank is where we have always housed all of our sand tiger sharks. And initially upon opening, we had both sand tigers and brown or sandbar sharks. Currently, we have three black-tipped reef sharks, one white-tipped reef shark, and 7 sand tigers on exhibit. So our current population, so if you head over to Discovery Bay tonight, you kind of get a good look at our sand tiger sharks, just so next time you go and look at them, you can kind of help, or you can see who they are. Pretty uncreatively, we have Uno and Dos. It got creative a little while ago. We're calling them number 1 and number 2, and we decided to make that fancier. So we have 2 older males, that's Uno and Dos. They have been with us since 1997, so they're approaching 25 years old. So pretty old guys. They're kind of the skinniest ones in there, kind of the slower moving sharks. We have Grace, who is our current largest fish at the Minnesota Zoo. She's 3.5 years old. I would estimate her to be in the vicinity of about 6 to 7 feet long, probably upwards of 200 to 250 pounds. So she is a very large animal. I say estimate because we don't ever take them out and weigh and measure them. In my opinion, it's difficult to determine who that would be more treacherous for, the shark or us. So she is a wild-caught individual, and she arrived here in August of 14. Mystic is almost as big as Grace. In fact, from the viewing window down below, I have a hard time telling the two apart nowadays. She's a little bit younger, about a year younger, 3.5 years old. She came from Mystic Aquarium, so we named her Mystic. So that name was taken when we got our other 3 sharks, so from Mystic Aquarium. So Osiris, Cleo, and Cato are the same age as Mystic, slightly smaller, but they just arrived here last fall. So they are really new additions to our shark reef exhibit. So why did we pick sand tigers? And that's kind of a big question for most zoos around the world even. You go to zoos or aquariums, you're probably going to see sand tigers in the collection, and that's because they are very readily adaptable to aquarium life. They don't run into walls. They live with other fish really well. You don't see great whites in aquariums, and there's a good reason for that. They're not highly adaptable to aquarium life, whereas sand tigers are. They readily accept frozen food, which is very important. We don't really want them eating their aquarium cohabitants. They're moderately large shark. We do want that wow factor, so when people come to the zoo, they can see a big shark. And these guys can get upwards of about 10 feet, although they're usually about 7 feet or so. And they're relatively non-aggressive, which is important for me because I do have to get in there to clean every now and then, and I would really appreciate it if they were not so aggressive to me. So they're not real avid hunters. I always tell people predators only hunt if they're hungry, so they're not real excited to hunt. They're going to eat the easiest meal, and that comes from us. So really, really great animals to keep at zoos and aquariums. So I don't like the word, but cons. What is kind of the bad news about housing sand tigers? Well, they're susceptible to something called kyphoscoliosis, which I'll cover in just a second. And they're extremely difficult to breed, which I will also cover in a second. And they're on the IUCN's red list as vulnerable, which Avery's going to talk about a little later. So these animals are in decline in the wild. So there is a concern that zoos and aquariums are pulling these animals out of the wild, and that is not lost on us. That's also a motivation as to why I decided that I wanted to get the Minnesota Zoo involved in helping wild sand tiger populations. So this is kyphoscoliosis. This was one of our males. So you can see, so kyphoscoliosis, you're probably familiar with scoliosis, and that's a lateral bend, so that's side to side. Kyphosis is dorsal ventral, so that's up and down. And he had a very pronounced both kyphosis and scoliosis. So you can see he's definitely not got that kind of straight shark shape that he's supposed to have. He's definitely kind of S-curved here. So this is something that sand tigers, and pretty much sand tigers only are susceptible to. We used to think it was only in aquarium animals, but people are seeing kyphoscoliosis in wild individuals, but not as frequently. And the thought there is that these animals are just being taken out of the population. They're not healthy individuals, so they're either not getting food or somebody else is preying on them. But we do see this in aquarium. This is a problem. It's a problem for health, it's a problem for longevity. So this is something that a lot of researchers are looking into. There is no smoking gun when it comes to kyphoscoliosis. There's a lot of research being done out there on nutrition, on flow patterns, on water depth, on water direction, even on catch, how they're caught in the wild. So there's lots of data being collected, but we really don't know exactly why they're developing this. Captive breeding. This is kind of AZA's big thing for sand tiger sharks. There are no AZA zoos or aquariums that have successfully had a successful baby born out of copulation in an aquarium setting. We don't know why. So we're trying to figure that out, and that really put me on the path to working with Avery. So AZA has said that this is a priority. We are an AZA institution, so therefore we need to start looking at our collection. We do have a potential breeding group. Our sharks are a little young yet, but in 5 or so years we're going to have a breeding group of sand tiger sharks. So how can we best set up this aquarium and these sand tigers to be one of the first zoos to produce a young sand tiger shark, or 2 young sand tiger sharks, even better. So I think 4 or 5 institutions have had successful birth of a baby that was bred in their aquarium, so we're kind of looking at what they did. But a lot of institutions are looking at what we need to do to get there. And one of the questions is another researcher that Avery works with, we had a great conversation yesterday. Temperature does look to be a really critical point for sand tigers. These animals don't experience a single temperature throughout their life. They're going to be migrating, they're going to be in and out of deep water, and those temperatures are going to seasonally fluctuate as well. So how can our aquariums mimic that? Also, basically, what does the wild ocean have that we don't? What does that water look like that we're missing? And so that brings us to looking at in situ sand tigers, or wild sand tigers. So we need to really look at what the wild sand tigers are doing to bring that back to our zoos and aquariums. Now there's a large deficit, even for these animals that we have had in zoos and aquariums for a long time. We don't know a lot about them, and that's why people like Avery are so important to helping us figure out and cracking this code of how do we get one live birth. And that was the chant at the last conference that we had a whole room, about 300 aquarists going, one live birth. So that's what we're hoping for. So what put the Minnesota Zoo, me and the Minnesota Zoo, on this path were really these conferences, and they're called the Regional Aquatics Workshops, and I can't underscore how important these conferences are. We basically get 300-400 of us in one room together to have these incredibly important discussions. At a couple of years ago at New Orleans conference, the Regional Aquariums Workshop, a man named Hap Fatzinger, who I wrote this slide last week, and then I found out that I've already screwed it up. So he's not the director of Pine Knoll Shores anymore, he's the director of Fort Fisher. So another North Carolina aquarium, I was pretty darn close. But he gave a talk about sand tigers and about the work that he was doing on in situ sand tigers and really bridging that gap between zoos and aquariums, AZA, and wild sand tigers. I approached him after that and said, hey, I think I can help you with this. And here at the zoo, we have the Ulysses S. Seal Conservation Grant Program, which is my favorite thing about working at the zoo. And through that grant fund, I basically championed some projects, and we sent some money over. In 2016, we sent $2,500 over to HAP, and one of his researchers, Madeline Marins, she was tagging sand tigers, looking at particularly female sand tigers. And so we paid for some acoustic tags. So the Minnesota Zoo basically got into North Carolina waters and helped tag some sand tigers. And that's the first time we had done that. So I was really excited to be a part of that project. In March of 2017, that's when I digitally got to meet Avery, and we started talking about the next step in that program, which is what she's going to talk a lot about, which is the Spot a Shark USA program. And I proposed another grant to our conservation committee, and they approved it. And so we sent $5,000 to Avery to help out with the Spot a Shark USA. And I'm going to leave that all to her. She's going to tell you all about that. And then just this past fall, I was so excited to put in another grant application, and it was also approved. So we're sending $5,000 to further help Avery in her research. And this time we're helping her pay for some more tags so she can find out what these sand tigers are doing in the wild, which will translate eventually back to us. So how can we improve our aquariums and make them more habitable so we can get one live birth? So Avery works for this CSARC, which is a mouthful, and she's going to talk more about this, but I just wanted to throw this up there because this is a program, if you're not familiar with it, they are amazing. They're doing a lot of really great stuff, not just for underwater critters, but a lot of land critters too. Getting rhinos and bison and sand tiger sharks and southern stingrays and sea dragons and all these things that need conservation help, that need maybe help with reproduction in zoos and aquariums. So I wanted to throw them up there. They're a huge part of why I wanted to become involved in more sand tiger research. So I want to thank you for listening to me talk for just a few minutes here. I'm going to hand it over to Avery, this real star of the show. She's going to tell you all about the work she's doing, which I can't tell you how excited I am to have her here. She's from North Carolina, and I think she froze to death walking from her car into the building. So if anything, give her a round of applause just for doing that.
All right, well, good evening, everybody. Can everybody hear me all right? If I'm ever too loud or too quiet, just wave your hands, yell it out, please, okay? So thank you so much, Seth and Becky and everybody else at the Minnesota Zoo for having me. As Becky said, I am from North Carolina, and I have a whole newfound respect for you all for dealing with this cold, and I know this isn't even very cold for you. But my name's Avery Paxton, and as Becky said, I am a postdoctoral fellow with this mouthful of an organization that is a nonprofit that really highly focuses in on how we can conserve the species in the wild and the ones that we have in human care. and sand tiger sharks have been one of our main focus species recently. And let's see here. So today we're going to talk about a lot of things. I'm going to take you on a journey. We're going to go diving off the coast of North Carolina so you guys can escape the cold for a little bit and see what it's like where these sharks are living. And one of the things that we're going to be doing today is when we go offshore on our boat, most of the time these sites that we're looking at are off the coast of North Carolina. I'm going to keep it a mystery for just a second as to what they are, but we're going about 3 hours offshore, and this is one of the dive boats that we use to access these sites. So you can see all of our divers on the back. When we're ready to hop in the water, we've suited up. This is me hopping in the water, and then we're going to head down with all our gear about 100 feet underwater. And this is the coastline of North Carolina. So to orient you, you guys are way up here. Here we are in North Carolina. And the sites that we're looking at, where we really frequently find sand tiger sharks, are shown by these blue dots. Does anybody know what these blue dots are? Say it louder? Shipwrecks, exactly. So the coast of North Carolina is known as the graveyard of the Atlantic. There are hundreds of shipwrecks right off our coast. Many from World War II, when German U-boats, for example, came across the Atlantic and tried to sink many of the United States and Allied vessels. There's also shipwrecks from World War I. There's some even earlier, many from storms and just the shifting barrier island geomorphology. And I'm even showing you a few wrecks that are pretty far inland. But the ones that our team is looking at are the ones that are offshore. So this is where I live, right here. And we take, when we go out to these wrecks, about a 2 to 3 hour boat ride, usually to these guys, but we're starting to study the cluster up here as well. And so what does it look like underwater? Well, this is a particular shipwreck. This one sank in the 1800s during a storm. We're in about 95 feet of water. And all of that shadowy structure that you're seeing, that's the wreck. And we're going to get up close to it in a second, and it doesn't look like a wreck. Right? You don't see the jagged metal really sticking out, and that's because there are so many critters. We have sponges and corals and all sorts of other really fascinating invertebrates living on this structure. And then you also have these clouds of fish, okay? And the way I like to think of these wrecks is that they're oases for marine life. So if you're to go a little bit away from the wreck, as you can see here on this side, we just have sandy areas around it. So a lot of the marine life really aggregate here or concentrated here. And I haven't shown you any sharks yet, and that's on purpose, but this is another video I wanted to share with you. This is a particular site that's about 115 feet underwater, and the reason I wanted to show it to you is because it paints a little bit of a different picture, okay? We're seeing, it's not as colorful in this particular video just because the lighting we have, but we're seeing these huge schools of bait fish. And if we go back a second and look at the bait fish's response, you can see they're all schooling together, and then they all start to dart the other direction. And if you look really closely, you can actually see these really large predatory fish in the distance that are causing this response. They're about to come in this upper corner right here, okay? And so on many of the sites, we have these large predatory fish. This is a close-up view of them. These are jacks. They're about this big, they're fast, and they corral these glittering, silvery schools of bait fish into these massive balls. But one of my favorite things about diving off the coast of North Carolina is this, okay? This is 115 feet underwater. We're looking at the side of the shipwreck here, and we have a video camera that's underwater. There's no divers actually out here right now from this video. We have a video camera set up, and every 15 minutes it's taking these quick bursts of video. And you can see the sharks. These are sand tiger sharks just coming towards us, our camera, one after another. And the analogy I really like to use when sharing this video is it actually reminds me of me being in line at the grocery store trying to check out, right? It's just these sharks coming one after another. And if you look closely, you can see some up in the distance. There's one here. There's a few. It's a little hard to see with the screen, but there are a few more up there. And so scenes like this are pretty common off the coast of North Carolina on these shipwrecks, okay? And so we are commonly seeing aggregations of sharks, sometimes, 5, 10, 20 at a time, but oftentimes more than 100 on a particular shipwreck. All right? Which to me as a scientist is absolutely incredible to have this opportunity to study these animals in their natural environment in such high numbers. And so why are we studying sand tiger sharks? Well, they're a really, really interesting shark species. Okay, they grow to be about 10.5 feet long. The females are bigger than the males. And when a female reproduces, well, first of all, she can't reproduce until she's about 9 or 10 years old. A male can't begin to reproduce until he's about 7 or 8 years old. And in the wild, the longest living sand tiger shark that we've documented is about 17 years old. Okay? As Becky mentioned, some of the ones here at the Minnesota Zoo are much older than that, about 25 years old. But imagine, let's say you're a shark, you have about 20 years of your lifespan, you can't start to reproduce till you're about halfway through that. And mix that with the fact that when a female becomes pregnant, she keeps her pup or pups in her, she has actually 2 uteruses, 2 uteri. She keeps them in there for about the length of time that we as humans would. Okay, so about 9 months. And when that shark is able to have or 1 or 2 pups, she does so, but it's only every 1 or 2 years. So because of this, these sharks have one of the lowest reproductive rates among all the shark species that we have studied the reproductive cycles in. Okay? So super slow to reproduce. They occur reliably in these large groups at the same sites. And so because of that, these sharks are really susceptible to some of the threats that our ocean is facing, like the declining health of some of the habitats or underwater homes that these animals depend on, or things like fishing pressure that in the 1980s and 1990s, for example, was largely unchecked. And so sand tigers, they live worldwide. This map in blue, you're seeing the spots where we know sand tigers either still occur or historically have lived. And when we think about how sand tigers are doing worldwide, Becky mentioned something called the IUCN Red List. This is an international list. It's called the International Union for Conservation of Nature, and their Red List for threatened species. And what they do is they evaluate the information that we have on these species, and they tell us, are the species doing well or are they doing poorly in terms of their numbers? And if we look at this, the way I like to think of it is this spectrum. So on the far right here, we have animals that are really not doing well. They're extinct in the wild, so they no longer live in the wild at all, but they still live in human care in facilities like zoos and aquariums, or those that are completely extinct, so no longer here at all. And in the middle, we have this area where we have animals that are at varying risks of extinction. And so sand tiger sharks are right in the middle, right here. They are vulnerable, which technically means they're at a high risk of extinction. And this is globally, they're at that high risk of extinction. But it's a little more complicated because there's certain areas of the world where we know enough about this species to know, like off the east coast of Australia, that the animals that live there that are sand tiger sharks, they're critically endangered, meaning they're at a really high risk of extinction. So off the east coast of Australia, for example, there's estimated to be about 500 left. Other areas, like east coast of South America, also critically endangered. But again, where we are, it's vulnerable, but our government has gone in and said, all right, what we know from research is that we estimate these animals to have declined by over 75% in number. And these declines largely took place in the 1980s and 1990s when fishing pressure wasn't very well regulated. So since then, there's been a ton of progress at the national legislative level, and this species is what we call a species of concern, so it's prohibited for you to be able to fish for it. And so, let's see here. When we think about sand tiger sharks and trying to make sure that they're sustainable both in our care and in the wild, one of the things that is so striking to me when I first started studying these animals is that despite a lot of research being done on them, there are still so many mysteries, basic mysteries. So for example, one is that we thought these sharks would migrate north and south with the seasons. So they'd head up north to New England during the summer, and then come winter, they'd head back south to Florida, okay? And we thought that for a really long time, but now we're starting to wonder if there's actually sharks that are stopping in North Carolina year-round and staying there, perhaps related to their reproductive cycle. And that makes sense if you think about where North Carolina is. It's smack dab in the middle of this northern and this southern, or their summer and winter habitat. It might be a good place for them to carry out reproductive behaviors. We don't know exactly how long a female has, how long her pregnancy lasts. We think it's 8 to 12 months, but we don't really know. Until recently, we had no idea where the female sharks were hanging out when they were pregnant. We also do not know, we have no clue, where they are when they're giving birth. And so answering those sorts of questions are really important for us to be able to better understand and then start to protect and conserve this species and the places in the ocean that they depend on to be successful at reproducing. And so what are we doing about this? Well, our team is harnessing some really exciting and new technologies, all right? And so the first technology we're going to talk about today is one that is a computer vision machine learning. I know it sounds really complicated, like an algorithm. It's kind of software based. And what it does is it uses the same principle that we use when we look up into the sky, and I know that a particular set of stars makes up the Big Dipper because I can know the spatial arrangement of those stars relative to one another. We can use the same thing for sand tiger sharks and their spots. And I'll connect that for you in a few minutes, I promise. The next thing we're using is laser beams. The other thing is marine robots, okay? And then we're also using acoustics, so sound underwater, as a way to learn more about these animals and actually follow their progress and their movement over time. And so we're applying all of these 4 technologies to sand tiger sharks. So you ready? Yes. Yeah? All right, so we're gonna dive in. So first thing, we are tracking sand tiger sharks using photographs, all right? So when you look at a sand tiger shark, what are some of the really distinctive things that you see about it? I'm going to pick on you in the front. Okay, what do you see? What are some of the distinctive things?
Well, 2 things jump out at me.
Okay.
The spot pattern and the very visible teeth.
Perfect. So, what's your name?
Bill.
Perfect. Thank you, Bill. So Bill said that 2 things really jumped out at him. One is the super kind of scary looking teeth. And that's one of the things that makes sand tigers actually such a great ambassador for ocean conservation, is that they do have this characteristic kind of fearsome shark appearance. But they're really docile, so they're great for us to have in human care. The second thing that Bill said is that there's these lovely spots along the sides of sand tiger sharks. So what we're doing with our colleagues is we've been able to use these spots kind of like a fingerprint. So my fingerprint, if I were to go to the police station to get my fingerprint taken, that pattern belongs to me and only me, Avery Paxton. But it's the same thing for a shark. This pattern of spots on this particular illustrated shark belongs only to that shark, no other shark. So what we can do is we can take photos of the sharks, look at their spot patterns, so we map where those spots are, compare it to other photographs of sharks to figure out if we're looking at photos of the same or different sharks. All right? So, quick quiz. 2 sharks, top shark and the bottom shark. I want you to look at their spot patterns, and I want you to raise your hand if you think these are different sharks. Okay? And raise your hand if you think these are the same sharks. All right, so these are in fact the same sharks. I'm going to map just a few of the spots by putting red dots on them. So we're going to do it on the top shark, we're going to do it on the bottom shark. And if you look, you can see it's the same pattern. It's just that they're rotated a little bit, right? So this computer program that we use, what it does is something similar. We go in and we actually manually put those spots, the dots on top of the spots of the shark, and then the computer goes in and says, all right, this is the spatial arrangement of these spots on a particular photo. This is the spatial arrangement of the spots on this particular shark photo. Are they the same or not? So again, similar to how we would look up into the sky and say this is the Big Dipper or this is Orion's Belt, for example. And as we go today, I'm going to put the little icons of the technology we're using at the top just to orient you. All right, really interesting thing about this particular shark is that in both photos, this is a female. She has fishing gear coming out of her mouth and trailing a little bit behind her mouth, all right? So we can use distinctive features like that to help us ID the sharks a little bit more than the spots as well. And this particular female has some scars beneath her first dorsal, or her top fin. So this is a technology that I'm really excited to share with you all because it's an opportunity for each and every one of you in this room to get involved, all right? You can use this technology right here with the sharks that are in human care at the Minnesota Zoo. You can come to any of the other places that I've showed you so far that have these sand tiger sharks and take a photo of them, all right? When you take your photo, you then submit it to this program we have that Becky mentioned a little bit about. It's called Spot a Shark USA. We then go in, map those spots, and figure out if the shark you photographed is a new shark, one that we haven't seen before, or if it's one that maybe Bill saw a few years ago and then Becky saw recently, and then we know, all right, the shark Bill saw was here at such and such a date, Becky saw it here, and we can start to connect the dots of where that shark was. So, this particular shark, this is one shark. We first saw this female shark up here on a particular shipwreck. It's 115 feet underwater in September of 2016. Fast forward 10 months, same shark, same shipwreck, all right? But in the first picture, if you look closely, there's no fishing gear near the shark's mouth. In the second picture, there is. So this is an instance of us learning a really, I just can't tell you how much information we're learning from just these two pictures. So we now know that this type of shark off the coast of North Carolina is returning to the exact same wrecks. In this instance, 10 months apart. That's something new that we did not know. We also know that this particular shark, sometime in the 10 months between the older and the more recent photo, she encountered fishing gear. We have no idea what happened to her in between, right? We have no idea where she was 4 months after the first picture was taken, but we do have these two snapshots, these two time points that really help us connect the dots and start to answer some of the puzzles for this shark. So, Spot a Shark USA, we launched it in June 1st, so what, about 6 months ago? And to date, we have identified over 100 different sharks from photographs submitted by folks just like you. Folks who are divers, folks who are fishermen, anybody else who encounters one of these sharks while adventuring underwater or around the water. And I do encourage you all to check this out afterwards, and please do, we'd love for you to participate in it, okay? So what else are we doing to conserve sand tiger sharks? Well, this team that we're working with includes folks from the Minnesota Zoo. It includes folks from aquariums all over the country, as well as international collaborators, folks at universities and at the government. And we're doing some really cool projects that I wanted to share with you. And the first one is that I mentioned earlier that we have no idea where these sharks are giving birth to their pups, right? I also told you that until recently we had no idea where the pregnant females were even hanging out. So some of my colleagues, ones that were funded to do this work through one of the grants that Becky mentioned, actually tagged some of these sharks. And while they were tagging them, they took blood samples and conducted ultrasounds, just like you would on me if I were pregnant and wanted to see what was going on with the baby, right? Conducted ultrasounds. What did they find? They found that pregnant sharks were hanging out on the shipwrecks off the coast of North Carolina, all right? So the next thing we're trying to figure out is, all right, we know the sharks are here during certain times of the year and they're pregnant, but where in the world are they going to give birth to these pups? And that's a really important question, because if we know what areas of the ocean they're using for this really important function of giving birth to their pups, which are going to be the population of sand tiger sharks in the future, that's huge. So this is a photograph that one of our collaborators, her name is Tanya Huberman. She is a world-renowned underwater photographer, and she became an underwater photographer. She was a mathematician. She quit her job because she fell in love with sand tiger sharks and wanted to be able to tell their story. Okay? Look her up. Her work is absolutely incredible. And so Tanya works with us very closely on the Spot a Shark USA program. And she was diving several weeks ago off the coast on one of these shipwrecks, and this is the picture she shared with me afterwards. So this shark, it's a female, and I can't tell you definitively, but her belly looks pretty darn big, okay? So we're thinking that this female shark is likely pregnant. This is just illustrating this principle for you. And so how in the world do we go from that? Go from ultrasounds and blood samples telling us that these sharks are pregnant, photos suggesting that the sharks are pregnant, to figuring out where they're actually releasing those pups. Well, one of the things we do is we go fishing. So we take our boat offshore several hours from where we live, and we literally fish with hook and line for these sharks. Once we catch a shark, we bring him or her up to the side of the boat. If it's a female, we not only take blood samples, as you see being conducted here, but we also conduct ultrasounds, okay? For sharks that are in early stages of their pregnancy, very early on, what we then do is we do a small surgery. So we take this black thing, it's called an acoustic tag, we take it and we put it into the belly of the shark. This is my colleague Madeline, who you've been hearing a lot about. She has just inserted the tag and is now suturing it up. So those tags, they're really cool. We're going to say this is the tag. The tag emits, we're going to say I'm the shark, it's in me, the tag emits a uniquely coded signal, right? So underwater sound. And let's say you guys are my shipwreck, okay? And let's say your beer, can you hold that up? Or drink, might not be a beer, soda. Hold that up. So that soda is the acoustic receiver, okay? So they're the shipwreck, the acoustic receiver is attached to them, and that receiver can detect when me, the tagged shark, and my pinging tag is near them, okay? So it tells me, all right, shark Avery's here, all right, I move further away, it has about 500 to 1,000 meter detection radius, and now I'm not there. So what we do then is we are tagging these sharks when they're just beginning their pregnancies. We know approximately when they're going to be giving birth to their young. And so if we then figure out that yes, I'm present, the formerly pregnant tagged shark, on a particular wreck around the time I'm supposed to be giving birth, then that is giving us evidence that there might be pupping there. It's not definitive, but it's helping us narrow in our search. Okay? It's the huge first step that we need to take. The other thing that we are super jazzed about is that we've recently started using marine robotics and lasers to study these sharks. And so what we do is, who here has heard of a ROV? It's a remotely operated vehicle. All right, so some people have. What happens is we have a boat at the surface. The boat, that's where our center of operations is, okay? And we send a cable down into the water column with a remotely operated vehicle, basically an underwater robot, onto these shipwrecks. And then we drive it around. So I'm sitting on the boat. I have a video feed of exactly what this ROV is looking at as we drive it around the wrecks. And we're doing this on a select set of shipwrecks. They occur in this diagonal line around one of the capes about halfway down the coast of North Carolina. And why do we pick these wrecks? We picked them because they are in a line. And if you're a shark that's presumably migrating north-south, you're probably going to pass on by these wrecks on your way there. Or if you're spending the whole year here, you might be hanging out here too. So we go in, and we weren't sure if this was going to work. We had this idea, wanted to see if it was viable. A lot of people said, no, you're not going to see any sharks with this remotely operated vehicle. They're going to be scared of it, and they're going to go the other direction. And we said, well, hold on a second. When divers come from all over the world to dive on these shipwrecks with the schooling bait fish and the jacks and these sharks, the sharks don't care. They're just kind of chilling, for lack of a better word. And so we found that the same thing actually happens with this remotely operated vehicle. So we have video cameras on the front of it. This is a frozen frame from one of those videos, giving us a head-on perspective of this curious shark, and then we can see this one headed off in the distance. This is the shipwreck right here. So in addition to the videos, we also have 2 laser beams that are mounted on the very front of this remotely operated vehicle. We know how far apart those 2 laser beams are, so when they shine on the shark, we know the distance, again, apart that those laser beams are. We can then use that to figure out how long the shark is, and then use that length to estimate how old the shark is, all right? And so I want to show you what this is like underwater. This is, it might stick a little bit, but we're just going to wait for it. This is one of those videos. So again, I'm topside, driving the ROV. This was one of the first times I'd actually driven the ROV, and let me tell you, I was telling some folks yesterday, it's actually a lot harder than it looks. But I think my little brother, who played a lot more video games than I did, would be a lot better at it. 'Cause a lot of the guys pick it up pretty easily, but I didn't have as much video game training, so I'm getting used to it. But you can see here that we are seeing sharks galore. And you can see in that freeze frame there, do you see those two laser beams come up? So this is the type of stuff that we're seeing. And while it looks pretty fun, right? It is fun. But what I'm here to tell you about is why we're doing it. So again, we're just trying to ask and answer these simple questions. How many sharks are on these wrecks at particular times in the year? Are there shipwrecks where we're only seeing female sharks and others where we're only seeing male sharks? Are we encountering sharks that look relatively pregnant? Things like that that are really helping us put the pieces together. So what about the big picture? Today I've shared with you all 3 pieces of this Sand Tiger Shark Research Collective that's happening. I've shared with you pieces that we're conducting in the wild in these sharks' natural environment. We talked about the citizen science program where anybody who encounters one of these sharks can take a photo showing the spots, and we can use it to identify individuals and track their movement over time. We then talked about how we're using acoustic technology to tag and then track these sharks to try to hone in our search for where they're pupping. And then we talked about how we're using remotely operated vehicles to look at patterns and how sharks are using these potentially key shipwreck habitats over time and over space in the ocean. And so, what about the big picture? Well, we started this conversation tonight by talking about how sand tiger sharks really aren't doing well worldwide. Off our coast, they've been estimated to have declined by over 75% in the past several decades. And so our hope is that through this research, we will be able to learn more about the species so that we can continue to protect and conserve them and the parts of the ocean that they require to be able to reproduce and continue to have 1 or 2 pups on a several year basis. And our hope is also that we can then apply this research that we're doing here to other areas of the world, like in Australia and like the east coast of South America, where these sharks are really not doing well and are at an extremely high risk of extinction. And so I want to conclude by reiterating that you guys, everybody in this room, you really can be what I like to call an underwater detective, right? So we have all these mysteries we're trying to solve about sand tiger sharks, what areas of the ocean they're using, where they're pupping, where they are when they're pregnant, things of that nature. And to answer those, we need folks like you all to be detectives, go and experience these sharks firsthand, take photos of them, submit them to the program, and that gives us the evidence that we need to start to solve these long-standing mysteries. So check us out, spottasharkusa.com. We also do have social media threads, so Facebook, Twitter, Instagram, out on as well. And I'd like to wrap everything up by, I think I skipped a slide. Let's see here. No, we'll just do it in a different order. I'd like to wrap everything up by saying that in a second, we are going to have a question and answer session. So if you guys have questions, you can certainly ask them to any of us, Seth, Becky, or myself in a few minutes. But you can also email me directly if you would like. There's my email address. And I want to thank an incredible number of partners that we have on this research. We are partnering with folks in North Carolina from the aquariums. We are partnering with CSAR, where I am employed, as well as Duke University, where I'm a visiting scholar. Our colleagues at the federal government with the National Oceanic and Atmospheric Administration. Many of the photos you saw today are from one of our colleagues, John McCord at the Coastal Studies Institute, who takes absolutely brilliant photographs of sand tiger sharks, as well as Tanya from Blue Elements Imaging, the folks who are behind the spot matching program that we use to ID the sharks from the photos. They are incredible colleagues, as well as funding from the Omaha Zoo, Georgia Aquarium, SeaWorlds, and Busch Gardens, and finally, the Minnesota Zoo. I would like to say a big thank you to all of you for coming out tonight to support the zoo, and especially to Becky for championing sand tiger shark research and making sure that you all in Minnesota are able to directly contribute to the conservation of this species in the wild. That's a huge, huge boost for sand tiger sharks, and we are really appreciative of it. So with that, I think we'll take some questions. Yeah? All right. You guys want to come up too? Okay. Go ahead.
So you present a lot of data that can be observational to tell you, how these sharks are behaving and what they're doing. What are your hypotheses in terms of why they're not reproducing in captivity? What can we do to change that? Is related to how there's, cap, pressure, temperature.
Definitely. So really great question. So the question was, we talked a lot today about some of the work that we're doing observationally in the wild. But what about the sharks that are here in human care, and what can we do to make sure that we're able to better reproduce them? Is that your question? Okay. So there are a ton of people, a lot of our colleagues who are working very highly on that project right now, trying to figure out, for example, if we look at wild sand tiger sharks and we extract their semen from males, how does that semen look different from the semen of the males that we have in human care? And of those differences, are any ones that might be associated with our inability to reproduce them so far in AZA, so Association of Zoos and Aquariums institutions. There's other things that we're looking at as well, environmental factors like Becky mentioned, temperature, food sources, so nutrients, and water quality, things of that nature. And so I don't have the answers yet, but we assure you we are working full steam ahead on trying to figure that out, because as Becky said, what's the motto?
One live bird.
There you go, one live bird, we're trying.
And I can answer that question from the Minnesota Zoo's perspective. So we are doing a few things. Like I said, our sand tiger population is not, our females are far too young yet. While we have 2 mature males who are probably ready to reproduce, our oldest female is 4.5 years old. And as Avery said, they don't reproduce until 10. So that's in the wild. So I have my question is that typically we see a little bit faster growth in aquariums. We have, they eat a bit more with us. So they are achieving their full-size growth a slightly bit faster in aquarium setting than they are in the wild. So we may be speeding up their reproductive cycle. So she may be a little bit ready a little bit earlier than her wild counterparts. But the way that I'm looking at it, as well as my colleagues are looking at it, is we have some time, which is great because usually time is a very limiting factor. So how do we put into place some procedures to get us ready so when she's ready to reproduce, or any of our females are ready to reproduce, we're ready to go. So a few things that we are doing right now, we've been doing temperature fluctuations on our exhibit for years now, which is actually, we're not, or we're one of a handful of institutions that can do it. So we've been doing seasonal temperature fluctuations. So right now, it's winter outside, so it's winter in the shark tank. So we're sitting at about 68, 69 degrees, which let me tell you as a scuba diver, that's really cold. And then it goes up to close to 80 in the summertime. So we are trying to get that seasonal temperature fluctuation, which may trigger some biological cues that tell them it's time to reproduce. Now we are limited by that, which is the kind of the biggest limitation with those temperature fluctuations, is we have some fish that aren't going to tolerate those cold temperatures. And so basically we're going to try to take that down as low as we think everybody's okay. And so then we're going to be looking at our Goliath grouper, some of our jacks, some of the other fish that we're not quite sure are going to be real happy at that colder water. See how low we can go. We're just trying to get that as big of a swing in temperature as we can. And looking at them behaviorally too. We're starting up with Disney and North Carolina aquariums. I had a long phone call, and we're developing we actually took her program, and we're using an iPad. We're using software to behaviorally monitor our sharks to see when are those cues. Are they starting to, be like, hey, what's going on? Or are they just, are the boys fighting all the time? So we're trying to also gauge behavior so we can see any fluctuations. So in the next 5 years, if we do start to see that, wink, wink, hey, how you doing? We'll recognize that as being that. So there are things we can start doing now with the benefit of we've got time. So we are starting to do some of these things. Some of these we have been doing, but as I said, this is a huge and tricky question that only 4 or 5 institutions have had any luck doing, and none of them within AZA. So it's really, really tricky, but I think that's the most fun. I like a challenge. So.
Can I ask a follow-up in terms of, does pressure play any significant role in the reproduction of these creatures? Because as a relatively limited depth of aquarium versus the depth of the ocean, does that significantly contribute to their reproductive cycle?
That's a really great question. So the question was, given that these animals in the ocean can go much deeper than they can in aquarium habitats, could the differences in depth and the associated pressure be contributing to this failure to be able to reproduce in human care in AZA institutions? I don't know. I don't know the answer to that. Do you know the answer to that?
I don't know the answer to
Yeah,
that.
I'm not sure if folks have looked at that. And the problem with, well, anyways, yes, I'm not sure if folks have looked at that yet. But I think it's certainly something very interesting to consider. And how you would test that becomes tricky, right? Because then do you build aquariums with much, much, much deeper habitats? Or, yeah, so we'll take that back. There you go.
Which would also be very tricky.
There you go. That would be very tricky to put the sharks under pressure.
And I think that's one of the benefits too with sand tiger sharks is they are not like these deeper, like great whites can dive down hundreds and hundreds of feet, which is an added problem with keeping them in captive settings. Sand tigers, and you can correct me if I'm wrong, but they're typically more of a shallower species, and they seem to, the rest of their biology tells us that they do just fine at pressure at 12, 13 feet deep. So I don't know. I'm not, unfortunately, I would love to be a researcher.
They are a shallower shark species in general, but we do actually, so I was on a research mission with some colleagues, and we were doing some deep remotely operated vehicle work on sites about 400 feet down, and those shipwrecks were coated in sand tigers. And I've heard instances of them getting to, gosh, I think it's 500, 600 feet, but then again, we're seeing the ones off the coast of North Carolina generally, and like 80 to 200 feet. And then we do know that oftentimes the sand tiger sharks are going up to an estuary off the coast of Delaware, so Delaware Bay. A lot of sharks will return there every season and use that area, which is super shallow. And then juveniles will head up a little bit further north and use shallow estuaries as well for nursery grounds. So it's a really good question. I don't know the answer. Yes?
Does your transponder, the tagging you use, does that allow monitoring of how deep they are?
So the question was, do the acoustic tags, those black things that I showed you about the length of my thumb, do those allow us to know how deep the shark is at any given time? Yes, there's flavors of those that'll monitor temperature as well as pressure, which we can then equate to depth. So we do have the ability to get that information. And so who here has seen like Mary Lee, the great white shark, and Catherine and all those sharks, right? So you can actually track their movement in real time. So the way those sharks are tagged is different than the way we're tagging sand tiger sharks. So those are called satellite tags, and they're usually attached pretty close to the dorsal fin, sometimes even on the dorsal fin. And what happens is when the shark breaks the surface of the ocean and is exposed to air, that tag will then transmit a location so you know where it is. Sand tiger sharks, though, are super tricky because they're not coming up to the surface as frequently. And when they are coming up to the surface, does anybody know why they're coming up to the surface for these guys? It's really unique. So they're actually coming up to the surface to gulp air. And then they use that air in addition to their large oily liver that most sharks use to control their buoyancy so that they can hover relatively motionless in the water. And so when they're gulping air, they're not up there for long enough for those satellite tags to reliably transmit. So that's one of the reasons we're going with acoustic tags. And yes, they have been tagged with satellite tags before with varying levels of success. So there's all different flavors, right? And as a researcher, it's how do we pick the best tool to answer the questions we're trying to solve, right? So, yes?
Do you only take females?
So the question was, do we only tag females? Right now, our efforts have really focused on females, but one of the things we're in conversations about is if we are fishing and catching males, do we also want to tag them? And my thought is yes, we do. But it's a resource question, right? If we only have a set number of tags and we're trying to really highly find out about females, do we want to put those tags on males too? And so we're having those conversations now.
So two sort of nuts and bolts questions
Yes.
about the research. You mentioned the stuff with the radio tag white sharks. I used to live on Cape Cod. And the kingers there that pick them up are at the surface.
Yep.
So I'm wondering how your devices, how the data gets from where they're moored underwater to you.
No.
And then secondly, how do you know their age?
How do we know their age? Okay, so the first question was, Bill has lived up near Cape Cod, and one of the things he would see there is that some of those receivers were closer to the water surface, and I presented on the ones that were actually mounting really close to or on those wrecks. And the way we get the data is we dive down, pick up the receiver with our dive team, bring it back up, swap out the batteries, offload the data, and then stick it back down. So it's relatively labor intensive, right? There are models that have been developed where you can do an acoustic release. So you can go out from the boat, send an acoustic signal down, and that exact acoustic signal will trigger the receiver to float and pop to the surface, which is pretty cool. And they use that a lot in deep water. In the depths that we're working in, though, it's just as efficient for us to use scuba divers. And with scuba divers in the water to retrieve the receivers, they can also take photos of the sharks feeding back into the photo program. And the second question was,
How do you know how old they are?
how do we know how old the sharks are? So there's prior research that's been done that has shown at particular lengths, particular body lengths, how old those sharks are going to be based on their physiology and, well, that's not the right word, skeletal
I was going to say
components.
word for a reason.
Yes, exactly. That's the word I'm looking for. And so we know that relationship pretty well. But again, it's an estimate, right? Wish we could ask the sharks and be like, hey, Shark Bill, how old are you today? When's your birthday? Yes?
Is shark behavior affected by light?
Interesting question. The question was, is shark behavior affected by light? I don't know if for this particular species their behavior is affected by light. What I can tell you though is that, this is kind of a roundabout answer to your question, is that we do see different behavior in these sharks in the day versus night. And so in the day, when we're diving on these sites, which is most of the time we're doing in the day, the sharks are relatively calm and not moving very quickly, right? They're kind of hovering and just chilling. But several researchers have reported, even up to decades ago, that when they had eyes in the water at night, the sharks were much more active. So one of the comparisons we're hoping to do this coming year is get eyes in the water through the remotely operated vehicles at night and see what's happening, right? So I don't know physiologically the exact answer, but ecologically, different behaviors.
Are there,
Oh, Becky has an answer to that question. Oh, you were what? Oh.
there has a question.
Great.
With a 75% decline and a fairly low reproductive rate, what do you believe to be the outcome? Are they going to be able to come back?
So the question was, with a 75% decline and what I told you about them having one of the lowest reproductive rates among sharks, what's the outlook for sand tiger sharks off our coast? So some of those declines, interestingly enough, have been estimated to be 75%. Others have been estimated to be lower. Some have been estimated to be 99%. And one of the most shocking things that I think you guys will find out of this whole evening is that we do not know if the sand tiger sharks off our coast are still declining, if they are increasing in number, or if their numbers are stable. And so it's programs like this where we're trying to collect as much information as we can on individual sharks through those photos that'll help us be able to estimate what that population size is, but we have a long way to go before we're at that point. So I don't know, but I have a chronic problem, which is I'm an optimist. And so whenever people ask those questions, my response is that I think there is a lot of hope still. And it's people like you all coming out here tonight on your Friday night to go to the zoo and have some beverages and learn about sharks, right? You can take this information back and make small life decisions that may influence shark conservation, whether it's I don't know, what's the next big holiday? Easter, for example. You're at the Easter table with your family and you're saying, oh, well, hey, I learned this about sharks, and what are you doing to help save sharks? So. Seriously though, I was teaching a course for Duke University alumni, and we concluded the weekend course by saying, what are you all going to do to protect sharks? Because that's one of the things that they were so stunned about, is that, actually, quick question. Who here, who can name 5 shark species? Just put your hand up. Okay, who can name 10? Who can name 20? Who can name 50? All right, does anybody know how many species of sharks and rays there are?
Roughly 400.
Yes, so there's roughly, so that many sharks, but if we look at sharks and rays together, we're looking at about, gosh, it's like 1,100, somewhere in that ballpark, which is astounding, right? I can't even begin to name that many. And of those, the IUCN, that International Union for Conservation of Nature, they've looked at the information they have on sharks, and of those sharks and rays, approximately 1,100 species, 25% of them are ones that are considered safe, meaning they're of least concern, okay? And then it's like 45% of those, we do not have enough information to even evaluate how they're doing. And then the other part, those are the ones that are much more at risk. So it's a big problem, but I think there's a lot of optimism and a lot of hope moving forward. In the back, yes.
When you talk about your problem of getting reproduction in captivity, I hear you talking about temperature, but it seems to me, just with my limited experience with natural systems, that you've got multiple variables. And how do you plan to try and isolate individual variable causation into a total effect on their behavior?
Do you want to answer that, or you want me to?
Well, sure, I can start. So we had a career highlight conversation yesterday. A bunch of us experts sat in a room and asked that very question. And one of the researchers that we talked to, she's looked extensively into lots of these things that, why can't we get this done? And she said, and she summed it up very perfectly, is that we need to know what is in the wild that we cannot or have not been replicating in captivity. So we're looking at temperature, we're looking at salinity, and one of the commonalities between the 4 and 5 institutions that have had reproductive success with sand tigers, we laughed because one of them is that they have natural seawater, which I volunteered to go get our seawater for us. I think the management thought that might not be very cost effective. But we are very isolated away from oceans here in Minnesota, so short of hiring tanker cars on trains, we're not going to get natural seawater here. So how are we going to look at all those parameters that we talk about? Temperature, salinity, the ammonia cycle. We're looking at ammonia, nitrite, nitrate. We're looking at pH. We're looking at all the salts in the water. Are we doing enough? We know that our replicated salt water is biologically sustainable. We've got 2 sharks in there that have been living in there for 25 years. So we're doing something right, but we're not hitting what they need to reproduce. So temperature is low-hanging fruit. We can do something. Not all aquariums can. We can. And so Dr. Jen Wiffles, who is a coworker of Avery, she has looked a lot at temperature and sperm count, and noticed a lot of discrepancies between wild males and captive males, and that in captive males that don't see any temperature change, they have no motile sperm. So the boys aren't able to get it done if they're not seeing that temperature. So temperature seems like it's a big clue based on Dr. Wiffles' work. So that is something that the Minnesota Zoo can contribute to. Now, can we contribute to anything that has to do with real live ocean seawater? No, unfortunately not. So we're not going to be able to do it here, but we can participate in the science in that way. So, and then doing the best we can with the rest of it. Can we set up a denitrification system on the tank to take care of elevated nitrates on the system? Yeah, maybe. Maybe that's something that the zoo can invest in, and maybe that'll get us a step closer. But we're always just trying to get a little bit closer to that wild ocean that sand tigers are reproducing in just fine.
Excellent. And I'd like to add to that answer that it's hard, right? How do we isolate one particular factor? How do we figure out if it's causation or correlation, just like you said? And it's a challenge. It's a big challenge. Yes?
The night observations that you had, is that done with artificial light or with very low light sensitive equipment?
The question was the night observations that we have of sand tiger sharks exhibiting much higher activity rates. What type of light was that with? So that was done several decades ago, the last time I know about it. And it was using, I believe, white light, I'm not sure, which to me thinks, all right, well, of course they're going to respond to that, right? So we're actually in conversations with some professional underwater cinematographers right now of how can we replicate this? How can we go out at night and try different, infrared, for example, and things of that nature to not elicit a perhaps scare response in those sharks that would increase that behavior. We want to see what's happening naturally without us adding an extra disturbance in. So
And
on
I
our
want to
list.
talk about another factor in captive situations is we have not natural sunlight lighting our tanks, so that is something that we're looking at too, a more natural seasonal daylight-night cycle, so that we're providing them with a more natural light as well and trying not to scare them by switching lights on and off. They're sensitive.
And I think somebody in the back has had a question for a while. Yes.
I'm wondering if they have a breeding season. You said you catch them and ultrasound them. Are they at the same level of pregnancy, or do you see very little pregnancy and then those that are very pregnant at the same time?
That's a really interesting question. So the question was, do we know what their breeding season is, right? And so when we ultrasound them, we can tell that they're pregnant. We don't yet know enough really to distinguish very highly amongst the different phases of pregnancy, but we're starting to get that information. But we're usually starting to see the pregnant females late summer and into early fall, mid-fall sometimes, and we suspect that pupping is happening sometime in the spring. And we have a few clues as to where the sharks might be pupping, and that's where we're really strategically trying to put those acoustic receivers out to see if our tagged sharks go near them. And we've actually have, I think, 3 now eyewitness observations that I've heard about from scuba divers who have been in the water and looked over and, oh my gosh, there's a cloud and there's a big shark and then there's some small sharks, right? So they have, in all likelihood, witnessed some of these sharks pupping on the shipwrecks. But at the same time, we have evidence from fishermen that they're seeing these sharks, and I say small, when they're pups, they're about 3 feet long. That's a big baby shark, right? So they're seeing these about 3 foot long sharks in some of the inlets, nearby the inlets, in the estuaries. And so we don't know if maybe most of them are being pupped there. We're just trying to get our bearings. Yes?
Is there a way to make sure that you're not identifying like shark A from the right side versus shark B from the left side as 2 different sharks?
Yeah, sorry. The reason I'm laughing is because Seth and I had this conversation very extensively yesterday, and it's a fantastic question. The question is, we're taking these photographs, right, and the spot patterns are not the same on the left and the right sides of the shark. So the question is, could we be, I said we have 100 sharks, could there actually be 50 sharks? Yes, that's totally possible, and we don't yet have a good way around it. From a scientist perspective, one thing we can do is if we're moving forward with generating reports and things that managers are going to be using, we would just pick one side. We'd say, all right, here's our left side sharks and here's our right side sharks. Take them as you will. But one thing we're trying to spread the word about is if you're out there perhaps underwater and you have an opportunity to take a photograph of both the left and the right side of the same shark and know it, tell us. Please. It's really valuable information, but it's hard, right? And this was our conversation yesterday. How do you have divers like, okay, hold still, shark, let me get your left side. All right, now your right side, right, spin. Didn't get the angle right, try again. Yes?
Follow-up, is there any difference in their dorsal fins, like in shark?
That is a great question too. So the question was, in addition to spots, can you, I'm going to go back and find a quick picture. Maybe. Okay, so the question was, can you identify these sharks based on the geometry or the shape of their fins? What do you guys think? Who thinks yes? Who thinks no? Who has no clue? Okay, great. So we didn't have a clue until really recently either. And there's a fantastic undergraduate, her name's Erica Blair, she's at Duke University, and she's doing her honors thesis on this very question. And the answer is that for dolphins, right, you can identify the individual dolphin based on the trailing edge, usually, of their fin in that pattern. We have gone through thousands and thousands of images of sharks from the United States and from our colleagues in Australia. And we had about 5% accuracy in identifying sharks based on their fins. But the way we were doing it was with a computer program that had been trained on dolphins, right? So very different fins. They're looking at one dorsal fin, whereas we really want to be looking at 1 and 2. And it was trained for things that were taken above water, right, when that dolphin is at the surface, whereas we're looking at underwater, so very different image properties. And so we've since gone back and done it a bit more manually, and we've increased our accuracy to 20%, okay? So we're getting there. And the reason we started down this path is because if I were to look at 2 photos of sharks, my eyes were gravitating towards their fins, right? And there's some with really distinctive fins. So we don't know yet definitively if we can, but we're trying. Yes.
Are you seeing a balance of males and females on the wrecks, or is it just primarily females?
So the question was, are we seeing mainly males or mainly females or some of each on the wrecks? And the photos we've been getting are a lot of females. And it's really interesting because at certain times of the year, we hear anecdotally that females and males are on the same wrecks, and you can actually see, when these sharks mate, there's a lot of scarring and it's pretty vicious. And so you can actually see some of those wounds and scars. But then other times of the year, there's sites that you only have males on, you only have females on. So we're trying to parse that out with the ROV surveys and the photographs as well. So stay tuned.
I'm going to be the bad guy and tell you get one more question.
Okay, I'm going to go with you. You've had your hand up for a really long time.
Thank you. I don't think I'm clear on, among AZA zoos, how far has the breeding process gotten before it was unsuccessful?
That's a great question. I don't have a great answer for you. Maybe Avery's heard a little bit more. But I know I can tell you here. So years ago, we had our 2 boys that we still currently have on exhibit, the 25-year-old males. We had a younger female, and we were seeing reproductive behavior in those. And basically, if you are not familiar with shark love, it's quite vicious. Basically what happens is the males will go ahead and bite the females. And as far as we know, this happens with all shark species, but if you remember back to the smiling shark picture, those teeth are pretty big. So the males are grabbing a hold of the female this way. And it, evolutionarily, female sharks have evolved skin that's twice as thick down the sides of their bodies to accommodate this, so that it's totally normal. But what would happen is we'd come in the mornings, because it was always happening at night, and they would look gnarly, unbelievably ugly. And not just her, because if she wasn't interested, she'd just turn around and bite them back wherever she could get a hold of them. So our boys, their faces would be mangled, their sides, their tails, wherever she grabbed them, she would bite them. Now the good thing is that elasmobranch immune systems are fantastic, and within a week, they were already starting to scar over. So really wasn't anything that we were worried about from a husbandry standpoint, but we were seeing it. Now, were they successful? No. We actually have a video. It's a very old video, so old that it's on one of those cassettes. So I don't know if anybody's tried to get it on a CD yet, but we should, because it's really cool. And I have to kind of put down the microphone to do this, but we got a video of our male and our female biting each other. But if my elbows are their tails, they were like this. So they were about as far apart as you can get when it comes to breeding. They were not parallel like they should have been. They were kind of like this. So they were trying. They weren't getting it right. So we are, one institution. We saw that. Unfortunately, we lost our female, and now we're working with the population that aren't quite old enough yet. So we're hoping that we're obviously doing something right since they were trying. Now, as far as other institutions go, I don't know. Do you know how many or what?
I don't know the statistics off the top of my head. I don't, but I think there's a lot more monitoring that's happening now. And so my colleague, who you mentioned earlier, Dr. Jen Wiffles, she's been going and doing quarterly exams at many of the AZA institutions to really try to monitor the year-long and even multi-year cycle and see what she can learn and see if she can isolate it. But again, I just hate to say it, it kills me as a scientist, right? But there's so many mysteries. But I think that's one of the really exciting things about this is that through collaborations like this one with the Minnesota Zoo and the Minnesota Zoo Foundation, we're able to start to be able to really pick away at some of these questions and find some answers.
And this has really become an AZA push within the last couple of years. I think, you know, I've been doing this for 19 years. I've known for 19 years that sand tigers just don't breathe in zoos and aquariums. But within the last, I would say even 5 to 10 years, we've really seen AZA going, okay, we need, you know, shark populations are in decline. We can't justify pulling them out of the ocean to bring them to you guys so you can see them if we can't put something back. So we really, really, really want to do something to help those wild sand tiger populations and figure out how we can captively breed them so we're not pulling resources out of the ocean anymore. So I know a lot of institutions, Georgia Aquarium, Disney, North Carolina aquariums, Connecticut, New York, New Jersey, mostly aquariums along the East Coast are really, really, really doing a lot of research, getting really hands-on with their sand tigers. They're playing the berry white. They're lighting candles. We're trying everything that we can to get these guys to do this because, like I said, and I'm not joking, imagine 300 aquarists sitting in a room going, one live birth. That's a lot.
Good answer. Yeah, was that it?
Do you have closing comments?
Okay, one more. Yes.
The very few live births that you've had, were they live? Were they ocean born? Were they sea born, or were they captive born? And is it like a behavioral thing?
Whipping cream.
Oh, yeah, that's a good point.
Do they not know how to copulate?
There were some in other countries, and I believe those animals were caught potentially when they were already pregnant.
Yeah, I think the Australian ones
That was
were caught,
Australia, yeah.
the females were caught pregnant and then birthed in an aquarium, but I think there are, out of those 4 or 5, there have been some that resulted in copulation in captivity, resulted in a live baby born. But we're talking 4 to 5 institutions worldwide, none in the US, none in the AZA system. So I believe it was Australia. I know the Middle East recently had some success in this. I'm trying to think of the other one.
And so there's also a big international push. So it's not just within the AZA associations. And so CSARC, for example, convened, because it was, last year, 2018, international group of scientists to try to start to address some of these questions and workshops teaching folks from other countries, like what we've learned from the ultrasounds and how we can apply that. And those folks and other institutions teaching us what they know and just really this impressive kind of capacity to share the research, whereas a lot of times I think the public perception is that scientists want to have their data and keep it close, right? But this is completely breaking that stereotype, and it is this really collective effort where everybody's coming together and saying, all right, we have these 7 animals, this is what we know, what can we do to make some minor changes in temperature or nutrient levels to try to get at the root of this problem. All right, well, I think that'll be it. But I'm going to stick around for a little bit, so if you guys want to come up and talk, feel free. I think Becky and Seth will also be here for a few minutes, and I'll turn it over to Seth for some closing comments, it sounds like.
Yeah, I just wanted to say thank you all very much for coming out. Drive safely and stay warm. And let's give a round of applause.